Hi, I'm an old guy and I do maths. And today we're looking at a very easy problem and a problem that may not be so easy. Uh, so let's deal with this problem first. 1.9x equals 5. It's a simple rearrangement. Make x the subject. 5 divided by 1.9 is equal to x, so x, according to my calculator, is equal to approximately 2.63. That's not a big deal. And those of you watching this video should have no trouble with this. What happens, however, when we're not dealing with a coefficient, as we are here, but we're dealing with a power? How do we solve something like this? And the short answer is we use logarithms. So let's go to work. But before we do that, it would be a good idea to have an approximate idea of what x is worth. Now, what we know is we know that 2 to the power of 2 equals 4. And 1.9 is very close to 2. So if we were just to sort of mentally substitute 1.9 with 2, 2 to the power of what would equal 5? Well, it would be more than 2 to the power of 2. And it would be less than 2 to the power of 3, which gives us 8. So it's somewhere in the middle of these numbers. And as I said, 2 is close enough to 1.9 for us to make an educated guess about what this number here actually is. My guess for what it's worth is that it's somewhere in the middle. It's around 2.5. But let's do it and see. Now, how do we do this? Well, we take the log of each side. So we'll do this in log 10. 1.9 to the x is equal to log 10 5. Okay, that's the setup. Now, you need to know a few log laws to make this really work. You certainly need to know one anyway, and it's this one. We still have a problem with a power up here. So what we're going to do is we're going to rewrite this side of the equation like this, which we are able to do. Log 10 1.9. Right, so this x can be moved to here. These are interchangeable. These two expressions mean the same thing. This makes life considerably easier because we now have x times log 10 of 1.9 equals this. And suddenly this is beginning to look a little bit like this. Not a lot, but a little bit like that. Okay, so let's tidy this up. Log 10 5 over log 10 1.9. Okay, so it's time. Sorry, we'll just get that into frame for you. So what I've done is I'm multiplying on this side, so when I move this, I divide. It's as simple as that. It's very, very similar to what was done at the top of this page. Now it's time for the trusty calculator. Now, I'm using this calculator. It's a $30 calculator that I picked up at a convenience store. It's a good calculator. You don't need anything more. For working in log 10, you don't need anything more than this. So this is calibrated in log 10. So when you see that on your screen, it's log base 10. And what we're going to do is set it up just as on the page, log 1.9. So that's what we've got. And that's our answer, 2.5075. 2.5075 we'll say. My guess was around 2.5. It's not a bad guess. Now, we're going to put this to the test. We're going to raise 1.9 to the power of 2.5075, and what we should get is approximately 5. I've done some rounding here, so it's not going to be absolutely perfect, but here goes: 1.9 raised to the power of 2.5075. So that's that there. I hope you can see that. Let's push go and see what we get. Well, really, really close to 5. Near enough. Certainly 4 or 5 decimal places with zeros in means that we're really, really close. Okay, so this is the very basic way in which you solve for an exponent. And I should have made this point at the start, but I'll make it now. When you have a problem like this, when you're trying to solve for an exponent, whether it's in financial maths or physics or whatever, you're going to have to use logarithms. And so it pays to know how these things work. Thanks very much for watching. See you next time.